All right, I'm going to do question 27 as well, which is similar to 26, but the main difference is the gradient is going to be slightly different. Okay. All right, the tap on a water tank is left slightly open, and 200 liters leaks every 5 minutes. So we have that piece of information is important. We know that the tank was at 2000 liters first, and then it starts leaking, and it leaks at a constant rate. That means 200 liters every 5 minutes. Complete the table of values to represent the number of minutes after the tap was left open, and n to represent the number of liters. Okay, at 0 we know that there was 2000 liters, so 0 minutes. After 5 minutes we started losing water, so just subtract 200 every time. So by 50 minutes there should be no water left. Okay, so we just need to graph this. This is a bit better graph paper, so we'll go there. Time, I always start by putting my units in the axes. This is minutes, and I've got volume of water, and that is in liters. Okay, so we know the volume needs to go all the way to 2000, so I can maybe go 500, 1000, 1500, and 2000. Okay, and time goes all the way to 50, so 10, 20, 30, 40, 50. Perfect. 10, 20, 30, 40, and 50 minutes. Okay, at 0 it's 2000. At, I think it's going up in 5s. Yep, at 5 minutes, so 5 is kind of the center there. At 5 it is at 1800. So at 5 it's there. At 10 it's 1600. At 15 it's 1400. At 20 it's 1200. At 25 it's 1000. At 30 it's 800. At 35 it's 600. Yep, so at 35 should be 600. Yep, that's about there. At 40 it's 400, and then 200, and then 0. So we can see that this is a negative gradient. Why? Because we are losing water over time. So this graph should look this way. And that's what I got. Okay, sometimes it's good to even have a heading, have a little title here. Water loss over time, or whatever you want to give a heading as. You can read the question and get yourself a better title. Okay, then it says determine the equation of the graph. I'll just do part C over here on the side because we need the graph. Like I told you before, always start with the general formula, y equals mx plus c, and we know m is the gradient and c is the y-intercept. To get the gradient, so whenever you have a question and it asks for the equation, you always will need to calculate two things: gradient and y-intercept. Y-intercept is kind of easy because we know it crosses the y-axis at that point there. So we already know it's 2000. So we just actually need the gradient. To calculate the gradient, we go rise over run. Okay, the rise is basically this part there, that's the rise. So that's between 0 and 2000, so that's just 2000. So we know the rise has gone up 2000, and the run is the bottom, which is 50. So the x-axis, I'm not going to draw it there, but that's the run. I'll just quickly show you. That's the run. So I did rise over run, and you should get 40. But remember I told you it's a negative gradient. Because it is a negative gradient, m equals negative 40. So now I'll just plug the things back into my original general formula. So I got negative 40x. I told you the y-intercept was 2000. And that is my final answer. If you want to go further, we can, instead of using y and x, we can use v for volume equals negative 40. Instead of x, we'll use time plus 2000. And that's it there. I would leave it as that, your final answer.